stood there, watching, waiting to possess you, to suck you dry. They have you surrounded. Flee the clutches of subscriptions. Wake from the middleman nightmare. Defend yourself against terrifying costs. Who will save the world from bad IoT?
Maybe this guy from Finland.
Who needs mobile masts anyway? Telecom.
Welcome all to the Wirepaths non-cellular 5G webinar. I hope the horror movie did find you well. We have more than 700 registrations and we are very thrilled and humble about the interest. It's about the same level that we had with Wirepaths Go last summer. I'm Teppo Hemiä, CEO of Wirepaths. We discuss today about the first non-cellular 5G standard. Before going to the standard itself, let's discuss why we need yet another standard on top of so many. So what's the horror all about? In our view, especially enterprise IoT has a real problem. There is enormous pressure to digitize more in various businesses to stay competitive, for better efficiency, sustainability, and safety. Digitizing means more data points, connecting more assets and processes. The more data points you have, the better it is for the algorithms like artificial intelligence and machine learning to run high. The question is how to do that with high return on investment, how to connect from thousands to millions in a cost-efficient way. We believe there are at least three fundamental questions to be answered when considering to connect in massive scale in enterprises. Additional data acquisition should always have an economical justification. When you go in scale, you very easily lose the benefit of the additional data if the cost of acquiring it goes too high. This works the other way around as well. The lower the cost of connecting is, the more connections you afford to have. For example, moving the needle from 5% of motors connected in a factory to 100% of motors connected makes a big difference to the predictability of operations and downtime. Another good question is, how sensitive is your data? Where do you execute it and where you store it? The answer can vary, but it's important to have options under your control and avoid dependencies with third parties. And thirdly, are you in full control of your connectivity availability? Or are you on public networks coverage and service levels? Is your IoT connectivity secured? We believe we have been able to create a technology and business model that gives a good answer to all those three questions. Today, I have three colleagues with me, and I hope you get the videos up and running. So they will tell us what this standard is all about. So I will first discuss a bit on what mission we are and why we end up to standardize this. Then we have Jussi Numminen, who is the head of RF at Wirepaths and also the vice chairman at Edge Technical Committee DECT. And he will tell you a little bit more what the standard itself is about. And after that, Jani Vehkalahti, our head of sales, will tell us that how that works towards our customers and what use cases will benefit out of it. And then we have Mia Karlsson, our head of marketing and communications, and she will explain some of the branding elements and our positioning. And then I will again close with the next steps and what we would like to do together. And we are ending the session with the Q&A, so you can already start sending questions in the platform, and we answer to as many as we can during this session. So let me first actually introduce our new spokesperson, Ville's mom. You met Ville already in the end of the horror movie. Ville is our CTO, and that's the real fact, and one of the founders, still a fact. And you will be finding Ville's mom in few videos going forward, and we hope you find them inspiring, entertaining for sure, but also delivering some important messages. So let's have a taste.
Hi, my son Ville made the world's best 5G IoT, in my opinion. I'm not surprised. Ever since he was a little boy, he liked hard work. Really hard. They started the company in a garage here in Tampere. You see, here in Finland, we don't complain. We get the shit done. That's why we have more tech startups per capita than any other country in the world. And more Formula 1 champions, by the way. Ville's idea was to make something faster, smarter, better and cheaper. A very good idea, I think. I just hope he doesn't become lazy like his father.
So, as you know, the truth often comes from the mom. Faster, smarter, better, and cheaper. I also think it's a very good idea. In other words, we are on a mission to make IoT mastery connectivity software affordable to any company. For the existing use cases, our mission is to connect in a more affordable way with better return. Our mission is also to enable new use cases, to connect the unconnected, something that was not economically possible before. That has been our mission already for a few years. And today we will tell more what the new 5G connectivity brings as well. The powerful combination of latest modern mesh technology with modern radio physical layer on a dedicated free-to-use global spectrum. Recipe to make the massive IoT happen for real. We started to plan for this step a couple of years ago, and we felt that the Wirepaths Massive, our current product that we renamed, has the feature and KPI levels enabling the massive IoT to happen. It has been developed together with the leading companies from different verticals, and we are very thankful for that, and relatively fast, thanks to the full focus on the connectivity stack software. Standardization was our obvious target. We embrace open standards and open APIs that brings the scale and broader acceptance, and it gives better interoperability. We are committed to continue contributing to this new standard, and we are also very happy to see very strong industrial support for it. So the long journey has paid off, and it is time to announce the world first non-cellular 5G. Finally, and with that, I hand over to Jussi, who is much more capable to tell more about what it is. Jussi, please.
Thank you, Teppo. So yes, my name is Jussi Numminen, and I'm going to tell you now a bit more about this. What is this non-cellular 5G all about? So the 5G is a generation name for the technology requirement defined by the ITU. So people have perceived 5G as a 3GPP technology simply because of the lack of alternative technologies. However, 5G is not a single technology, but contains a different technology foundations. Efficient spectrum use and the increased communication needs are tackled by the ITU, setting a new requirements to the wireless communication industry. And this is the foundation of the different communication generations we have seen in the past. This process has resulted in new technology generations approximately every 10 years. For the 5G, the requirements set by ITU are called IMT 2020, which defines the set of requirements I will briefly introduce on the next slides. DEC 2020 new radio is on its way to be included on the IMT 2020 in October 2021. This would be the first technology which can be used without network infrastructure. And ITU is then maintaining the global core specifications for all IMT 2020 technologies. This is a triangle which is probably familiar for most of us. It shows the three main requirement areas for the IMT 2020: mobile broadband, ultra-reliable communication, and massive machine type of communication support. The main focus for the mobile industry is in the mobile broadband, requiring a high bit rate and high mobility support, and URLC for the low latency performance. The massive machine type of communication and ultra-reliable communications are both related for the human, non-human, industrial, and sensing type of use. So these are the main technical corners of the IMT 2020. However, this IMT requirements does not cover those numerous issues outside of the bare communication requirements, which will make the technology viable for the certain use. These are related to the autonomy of the operation, where the data is consumed, who can operate and set up the services using the wireless communication, and the diverse application requirements, to name a few critical aspects. The DEC 2020 new radio standard is designed to meet both MMTC and URLC requirements of the IMT 2020. What makes this lucrative is the fact that this standard can support both the MMTC and URLC with the same technology assets and foundation. These both areas of use are relevant for the industrial use cases. So what are the merits for the new standard? First one is that we have a symmetric radio supporting the TDD duplexing. This enables the single radio design which one can set up the communication system. So the single radio design reduces the design and testing complexity significantly. This gives a major advantage to deploy the systems to the market. Secondly, the state-of-art radio technology to address the reliability and performance. We have the modern OFDM radio access. We have a short transmissions for the low latency. We have a per packet synchronization for the battery operated equipments. And we have a fast layer 1 hybrid ARQ support, which is increasing both the latency and the reliability and the link budget. Thirdly, we have a future-proof performance improvements from day one, which means that we have a wider bandwidth supports built in on the standards from the day one, as well as the multi-antenna support. And fourth, the important, which is for us, is that we have a native mesh operation in protocol design to support the scale and density. So we can support the autonomous device-centric communication, autonomous role selection, over 4 billion equipments in the same network, and more than 60 million independent networks in our system, to name some major aspects of the new standard. And the fifth, we have a very advanced coexistence technology to support the operation in the shared spectrum. Then Wirepaths focus on new standard is on the massive machine type of networks. So in the previous slides, I explained briefly the standard capabilities in general. In this slide, we are illustrating the Wirepaths design objectives for the purpose to build the massive IoT. And our focus is on the massive IoT systems which can scale in size and area and density. We can benefit multiple features defined on the standard, bringing the communication performance to the next level. Modern OFDM radio and physical layer functionalities are improving the reliability and latencies on each hop. We can develop the whole system with a single radio design and reducing the time to market and again testing complexity. So this is also enabling a rapid introduction for new features as testing is more straightforward. As we are focusing on the mesh networks, we are benefiting on the reliable link performance on the new radio. At the same time, we can develop the multi-hop system as the mesh network. And the autonomous operation enables the infrastructure-less deployment as Teppo was introducing. And one more important thing is that we can operate this system on the 1.9 gigahertz frequency band. Then a few words about this DECT 2020 performance, which is already approved by the third parties. So this technology has been assessed by multiple universities and research institutes during this year and previous years. So we have a Leibniz University of Hanover being active on the link level simulations results, and then we have a VTT and Tampere University performing the system level simulations and performance analysis. And all these companies has been participating on the evaluation process within REPSI. So the more details on these performance analysis. This all information is available publicly on the internet. And in VTT, they have analyzed with the new NS3 radio system simulation, the DECT 2020 new radio functionality on the physical and logical layer. And their main findings are that we can easily meet the density requirements for the IMT 2020 MMTC scenario. They were able to model more than 4 million devices per square kilometer, and still also indicating on their studies that we can build a reliable communication even with 25 equipments on the square kilometer, which is indicating the scaling capabilities of the technology. They were also studying that what is the minimum output levels that the system can operate, and at least on these scenarios, we can also operate with the 10 dBm output powers and still have a reliable communication. The Leibniz University was doing the link simulations and improving the physical layer performance, and they used the several channel models and receiver configurations to see the performance of the system. And Tampere University was analyzing also the MMTC system performance and also comparing that what is the relative power consumption between the mesh and traditional star topology systems. And these are high quality analysis, so I recommend each of us to have a look on those in details. Then the new standard is ready for use. So the new standard is publicly available and ready for use. So it is the use of this standard which makes them more significant for the marketplace. So the TC DECT is progressing with the additional standards related to the DECT 2020 system and is evolving the standards as the new requirements are known. So please join on the ETSI work and to try the future work. So this completes on my part on the presentation of the standard, and now I will hand over to Jani.
Thank you, Jussi, and thank you, Teppo, for the introductions. Yeah, many of my questions quite often talk that, so what? What's in it for you and me? And that's what I'm trying to cover here. It's all about the business, and there's no question that the needs of the IoT in the world. It's all about how you make the business case positive and get things done. So one of the biggest thing impacting on IoT project in a total cost of ownership is connectivity. So it's super important that in order to make the business case positive is to take care of the total cost of ownership. So with Wirepaths, you can do the installation by anyone. And you don't need base stations. Wireless coverage comes close to zero infrastructure. You don't need the SIM card, no subscriptions, no cloud required. All of this is impacting in the cost side, and it's only depending on the connectivity. And then it's much more easier to build the value on the top of it. And how do we get there? It's about the mesh network. It's designed for a massive IoT from the day one. And you connect your devices, actually millions of devices, and all in the same network, nothing else. It's so simple. And I always try to prepare our customers that they be ready for the success. And what does the success mean? It means that you will have more devices. And you need to be able to reliably scale. So the more and more you add the devices, you still need to get the connectivity works. And that's what we provide, connectivity that never fails. And how do we do that? It's autonomous. So all the decision making is autonomous. It's decentralized. And in order to kind of scale anywhere, you need to have the coverage inbuilt. And this is how we do it. So any device you bring in a network improves the coverage, even underground. And the same mechanism is also providing a no single point of failure. So it's not about that you need to connect to one base station, 2 or 3 base stations. Every device nearby you are the possible point to connect. It and all comes with the years of battery life, still that you have a bi-directional communication, which is secure and it's future-proof thanks to over-the-air updates. So what do we build actually, and what do we provide? 2 products, Wirepaths Massive, that many of you might already know with the name Wirepaths Mesh, and then this new product that we have talked today, Wirepaths Private 5G. So for me, there is no one size fits for all. Forget it in IoT. Our playground is fit for purpose for the massive IoT. So it's not that this is a solution for the mobile broadband. It's about all that where we focus is to make this massive IoT affordable, functional, scalable. And Jussi already provided good proof points how the Wirepaths Private 5G is delivering a super good performance and unseen cost point, thanks that it's based on the mesh that doesn't require infrastructure. But we also have identified the use case that needs to get even lower cost points. And then it means a bit lower performing hardware, but it's possible. And that's for the Wirepaths Massive. So both of these works parallel. They both are needed in the market and both are solving the same thing, which is the massive IoT. And Wirepaths Massive, and I still tend to say Wirepaths Mesh, but it's Massive, is our original product. The connectivity which was designed for the massive IoT networks from the day one. And it's already deployed in the millions of devices. So even that we talk about today the new things, there is already a big deployments out there. It was built on the GFSK radios. The ones which are not familiar with the wireless, this is just a 4-letter acronym, but I think you are more compliant with that. It's like a Bluetooth low energy 2.4 gigahertz radios, but it can also operate other frequencies. It was made for the industry, which all we know have harsh requirements. We connect every sensor, every luminaire, every moving tag, you name it. And what is important, we've been already proven the high density and the scale, which are important in the massive. And we continue to strongly address the lowest cost option. While in the private 5G brings this performance even more better level. It's a world first non-cellular 5G connectivity. And I think this is one of the key takeaways from this seminar. You remember that the 5G does not equal cellular. And when we look the corner of the massive IoT, we outperformed in the 5G. It's on the free global spectrum in a 1.9 gigahertz. That's the second key takeaway that you should be remembering from this show. And it comes without the SIM cards, without the big infrastructure like we're covering, no need for the building a base stations. It's really designed for the most demanding environments, and like Jussi explained, that's already packed up with the good simulations with the third parties, and it comes with the longer reach, and still at the fraction of the cost of cellular. I think you have been hearing me to talk about the fit for purpose, but that's super important. Whenever you talk about the IoT, it's all about that. Our focus has been in 4 verticals: smart tracking, smart manufacturing, smart building, smart metering. Both of our products, Wirepaths Massive and Wirepaths Private 5G, they both are suitable on these sectors and all even beyond these. But if you look for what Wirepaths Private 5G can do more, is that the use case where you need the range, where you need even more throughput, even more reliability. Reliability comes from a couple of reasons. So the hardware itself, and the second thing is that it functions in a band where you can only operate by implementing the standard, where the Jussi explained about this spectrum usage. And then I give a few practical examples that where you can see the difference. So smart tracking, indoor positioning, indoor asset tracking, my Wirepaths Massive keeps on outperforming there. But when you look at the global logistic chains, Wirepaths Private 5G is a great fit. In smart building side, when you're connecting a indoor lighting, occupancy sensors, air quality sensors, Wirepaths Massive is a great fit. But when we go in a building management side, regulated smoke detectors, HVAC, that's a great fit for the Wirepaths Private 5G, delivering an excellent reliability and range. In smart manufacturing, we've been already proven that the Wirepaths Massive is a great fit for that use case to delivering quite a good data coverage and ease of installation. But there's no doubt some of the locations and IT policies are making it a bit difficult to deploy the 2.4 gigahertz based devices when private 5G operating in their own spectrum makes sense. Smart metering, we've been already proving a great performance in Nordic countries and Indian countries, India, where you can actually have a good regulation for the mesh. Now, if you look at the global market, private 5G is a great fit for the smart metering, delivering a great range, throughput, and global spectrum. So that said, I would like to play you the private 5G video and then pass to Mia, which is talking about the new things on the brand.
Enterprise IoT has a 5G problem. Because cellular wants to sell you stuff, they complicate things. With expensive infrastructure and middlemen. A lot of middlemen. Now look at Wirepaths. We are changing the future of connectivity. With purpose-built network, data and assets stay private. No backdoors open, no big infrastructure. On an open standard, dedicated free global spectrum. Just flat out better IoT for less of your money. So stop paying for nothing. We are the rebels of enterprise IoT, and we offer freedom. Freedom to create a network from any devices and then connect billions of them. Freedom to be totally scalable, big as you want, dense as you need. Freedom to have a network that never fails wherever it has to operate. That's how we do it. We get shit done without creating problems. Remember, you should own your network, not be owned by it. Thanks to Wirepaths self-managing private 5G, now you can.
Thank you, Jani. Now let's move on to the next topic. So those of you who are familiar with Wirepaths from the past, you have noticed for sure already that things look a little bit different from what they did. And I wanted to very briefly touch on that point in case you're wondering what is happening. So when you have a company that is growing and changing and frankly venturing out into new territories like Wirepaths is doing today, the brand needs to be able to handle that as well. And this is why we have spent past few months, frankly, soul searching as to who we are and what we want to represent. And we decided pretty early on that who we are is who we are, and let's not try to be something else. So this is what you're starting to see now in our new branding. We realized that it might come across a little bit unconventional. It might be quite direct, even blunt. Very likely not everyone will like what we say, but we still believe that this is what the market needs. If you look at the communication in the IoT market, it's very generic, it's quite feature driven. There are a lot of companies that are struggling to navigate between the different actors. So we wanted to bring some change to that. We wanted to bring our point across. And yeah, we also want to challenge the big narratives that maybe have morphed into market truth that we don't necessarily believe in. So this is just to say that we're trying to call the spade a spade. You are seeing something different. We are on purpose doing something different from everyone else in the industry. But in the end, when you look closer, this is who we are. This is something that is quite real. There's nothing artificial here. It's just the Wirepaths people and then the amazing connectivity technology that you have been hearing about. So I'm not going to take more of the time. Just wanted to give that feeling from where we're coming from, because I know some of you have noticed that there is a big change. And if you are a partner of ours, if you want to work with us on the marketing front, please do get in touch. We have a lot of material available already and are very keen to work together with you. And since Teppo already introduced our new spokesperson, Mom, and since you are, thank you for attending this webinar, we also wanted to give you a little sneak peek into the next episode of Mom, an episode that will air officially next week. But here we go. Enjoy the episode 2 of Mom, or a sneak peek of it.
I think young people are too soft. So when my son Ville wanted to build the best IoT company in the world, I said that's okay. But you are from Tampere in Finland. Don't be soft. I told him, so are you tough? Are you prepared? Or do you want to relax on the sofa and eat chips like a couch potato? Ville said, Mom, I want to be tough and take ice bath every morning like Finnish people. And eat barbed wire. So every morning we come down here to be tough. To prepare to be best in the world. Because I think there's a big difference between a swimming pool in Silicon Valley and an ice bath in Tampere. But if you want to buy your IoT solution from a guy eating vegan sashimi in a warm pool in Silicon Valley, that's up to you. Good luck.
Ääret kertoo meistä, elämässä eksyneistä, joita ohjaa tuolta jostain voimatonkin kohtalon. Ääret kertoo meistä, kaipauksen kätken.
Great, thank you, Mia. So now you can see how warmly we handle any topic, and I hope you enjoyed it. So all said so far means what? So what is the next step here? I think we all have seen that there are many standards out there, and obviously only adoption makes them meaningful. So although we are one of the main contributors of this new standard, we are not going to make it alone. We need everybody on board. And we are very pleased to see the strong support and interest. And some of that is actually visible also in our website, on the standardization pages. So maybe you take a time and have a look. And there is also very good interest for becoming a lead customers. And the product is available next year. So although we are still finalizing a new releases of standard, as we have pre-standard product already, we can be quite timely. And you know, as it is largely based on the same software as we have on Wirepaths Massive and the same SDK, the migration is very straightforward. So the work can start already today with our Massive product. And the two, Massive and Private 5G, offer outstanding coverage in the wireless space. And we really believe that there is an excellent business opportunity for the whole ecosystem, which is growing. You can also see in our partner web pages the number of devices already supported by Wirepaths software. So industrial IoT is the fastest growing wireless market, and no one knows where are the limits. It quite certainly becomes the biggest in volume, and affordability drives the market size, and that's really where we focus. And the performance, the market fit, where we also have proven many good use cases. So I believe that we have the both together with our ecosystem. Again, we are not making those products ourselves. It's a result of very strong ecosystem. So this is the first wireless technology designed for the massive IoT from the clean slate. Non-cellular, limitlessly scalable, decentralized connectivity on a dedicated free-to-operate global frequency band gives the best foundation to become the new standard for the industrial IoT. And the momentum is really mounting, and the pandemic is clearly accelerating. Supply chain monitoring is a hot topic, becoming more and more important. That creates growing demand for asset tracking. Condition monitoring reaches smaller and smaller assets thanks to the lower cost of connecting. Digital twins are easier to build when you have more data points. These times have such huge pressure to healthcare and efficiency there. Connecting assets increases the time spent with patients instead of finding things. And smart buildings are evolving with higher energy savings, CO2 reductions, and human-centric lighting. The energy sector is going through a big change as well. Decentralized production of renewable energy and smarter grids. And very importantly, what's common to all these industries is the desire to go for private wireless networks. Up to 84% of companies are considering to have their own local private network, according to API research. So let's make the massive start already now and get in touch. So Jani spoke earlier. Jani and his team is ready to have the discussions and go for going through your case and problems you might have. And now I think our main session is covered. So we are moving to a Q&A session, and we are all ears. So I have seen now that there is a very many questions arriving. So we try to keep some sense of those. Maybe Mia, you can help us to pick few to get started.
Absolutely, quite a few questions coming in. That is great. And maybe Teppo, you can answer first question on what's going to happen with the current product Massive, and are you going to standardize that one too?
Great question. So as you know, that is the foundation of Wirepaths assets so far, and that's largely the base for the contributions to this new standard, where the private 5G is the first product. So there's a lot of similarity. For us as a company, it would make a lot of sense to work on that further in the standardization domain as well, and that's really up to the standardization people, of course. But I think we are all clear, focusing on these standardization steps going as we speak. But I can assure that Wirepaths massive stays in the product portfolio, and in fact we expect that will deliver even higher volumes going forward, because it's really addressed the extreme of affordability.
Good, thank you, Teppo. And then I have a question here for Jussi, which is this the legacy Wirepaths or Wirepaths Massive 2.4 gigahertz running at 1.9? And what is the radio hardware?
All right, so this, as Teppo already started the explanation of the difference between the massive and the private 5G. So this is a different access mode what we have in this private 5G versus what we have in 2.5 gigahertz cases, and as such this is not the intention that we are operating on the 1.9 gigahertz. It would require us to have some level of standardization on this method before doing that one. The radio hardware what we are using for this one, this is something that me as a standardization person, I'd rather not comment on that one, but as Teppo was saying, that we will have a product available on early next year, so there are already activities on that one, but I'd rather not comment on that, but let the others to have a comment on that.
Thank you, Jussi. And I think the question was also, can massive be run on 1.9 gigahertz? No, it can't, because 1.9 is dedicated to the new standard.
And Teppo, anything you want to add on the radio hardware?
Yes, so we are working closely with our semiconductor partners, and well, you can see that, for example, Nordic Semiconductor has been active in the standardization and contributions to the layer 1. And we definitely continue working closely together.
Okay, good. Another question for Jussi, perhaps. Will there be a standardized data model as well?
Very good question, and this has been broadly discussed already in TC Deck as we speak at the moment. The idea what we have in Wirepaths is that we want to support multiple different application domains as such. So at the moment, if you think about energy domain or building automation or healthcare, they hardly will not have the same data models on the application domain. So we will have a broad discussion about that, and at the moment, my opinion on this one is that we want to support multiple different data models and not to dictate application and use cases to modify the existing data models as such. And we want to keep this radio level and radio stack as agnostic as possible for different applications, so application data models, so that it would be a multi-purpose on that perspective, and not closing any doors on this perspective.
Thank you, Jussi. And then there is a question to Jani. It is still not clear how it connects to the cloud. So device-to-device connectivity is clear, but what about cloud?
Yeah, I think that it's always challenging when you have 40 minutes to cover the new things. So there is a gateway. So this is the place where all the contains the data of the 1,000 devices coming in the gateway, and then it's a customer's decision, or let's say the one which is doing the solution, that where the data is pushed. So is the data staying in the premises, or is the data sent from the gateway to the cloud? Which cloud? So those are the decision making of the ones which are building the end-to-end solutions. So we ended up delivering securely the data to the gateways, and then from the gateway onwards, it's about the one which build the end-to-end solution.
Yeah, and Jani, maybe you can also answer another question on infrastructure requirements for smart metering specifically. So anything you want to comment more on that?
The great continuation. So in same way, you need to place in smart metering infra. So smart meters will create the coverage, they make the connectivity, but at one places you need the gateways, or like a DCUs, often called in data collection units in smart metering. So you need those. Then the kind of structure is still much more flexible because of how Wirepaths operates. You can actually use one of the meters as well to upload in the data through the cellular network out of the hundreds or thousands of meters. So all of these are the system decisions. So you need to have a backhaul connection, and yes, you need the gateway.
Thank you. Teppo, how about is joining in private 5G as in 2.4 gigahertz?
Yeah, so the question is, I guess, on the joining protocol and commissioning and provisioning. So I think it's good general question that the standardization starts from the bottom, if you like. So layer 1, layer 2, layer 3, and so on, and those are gradually built. And Jussi already mentioned that the data side of the standardization is then consideration as well. From Wirepaths point of view, our product has more layers than what the standardization covers, and this joining is one example as of today. Some of those things may also enter to the standard, and from our point of view, all the upper level things that we have today will inherit also with the private 5G. So you should be seeing similar functions, similar SDKs, and so on. Of course, there might be some gradual availability step when we introduce the first product.
Thank you. Yes. And how about the? Yeah, sorry.
So it's good to say that we already have received more than 50 questions. So I think that if you look the time left, that we cannot cover all. So if you feel that, oh, why my question was not answered here, so the reason is that we are getting lots of questions, which is a great thing.
There are many. So Teppo, bit rates and range for the private 5G product, what does that look like?
Yeah, Jussi could answer on the standardization part, but I may cover in a way that actually the standard gives a lot of flexibility. There are numerologies, from low to up to, I guess, 8 gigabits. If you take a full-blown, layer 1 capabilities. We as a Wirepaths, we will focus first on the lower side of that spectrum, but still more similar or better performance than what we are currently doing with the on top of Bluetooth chips. We bring especially range, robustness. The OFDM HARC capability is a big add. So from physical layer bit per second point of view, we are probably doubling to tripling the first product bit rates and target for hundreds meters to kilometer range of range. But those we will be clarified along the product development, and we will announce also more accurate timing and product features in that regard during the year.
Yeah, when I'm passing this to Jussi, I would kind of remind the fit for purpose. So it's all about that optimizing. Like if you want to have a range for a smart metering, you can get the range and with a bit lower throughput.
Yes, the standard numerology is such that we can scale from the 1.7 megahertz bandwidth up to 220 megahertz bandwidth if you would like. Then there is a question that is there a spectrum where we can operate with 220 megahertz bandwidth, but that is from the standard point of view is possible. Then we are also supporting on the physical layer the multi-antenna support. So this is basically giving us also a space-time diversity for the data, and this is giving the boost for the data rates if needed. of course, this type of functionality comes with the cost of the complexity of the equipment.
And maybe I could say all that I said in another way, that we target sub-gigahertz class of ranges, but with 100 to 1,000 times higher bit rates. So if we compare to the sub-gigahertz offering of
Thank you. Then Jussi, is Wirepaths private 5G part of 3GPP 5G standard?
Well, this standard is defined by HCTC DECT, and as it is not part of the 3GPP 5G standard. But as I was explaining on my part of the presentation, the 5G IMT technology families is a group of technologies, and we will be part of that technology. So the answer is that no, we are not on the 3GPP 5G specifications.
And maybe a follow-up question on this one then. So does this work directly with cellular networks?
Well, the physical is different thanks to the different frequency planning and for the DECT band itself. So this is a separate from the cellular system on that sense. Of course, the backend connectivity can be on the cellular system, but this is a separate from the cellular technology on that sense.
There's a question on IPv6, maybe you can continue.
Okay, the IPv6 will be part of the standard. That is actually a standard set what we are working at the moment, and the plan is that we will have that part of the specification also completed by the end of this year. So yes, IPv6 will be part of the. In the products, it's optional. In the products, we will have options that you can either operate on the IPv6 networks or non-IPv6 systems. So that would not be the only way to operate the system.
And from the business-wise, I can comment that the people might think that why I don't use the IPv6. So because in some of the applications, it's just the overhead. So when you want to optimize your use case, you want to get the best performance out. But when you need the IPv6, you have it.
Okay, and then if we take a question on the spectrum. So we say free global spectrum at 1.9 gigahertz. So how much spectrum? And is it available in India, US, Japan, and China?
All right, maybe I tried that one then. So yes, we have a 20 megahertz now in Europe, which is on the DECT spectrum, and also there is a different applications which you can use on a national basis from 1900 megahertz to 920 megahertz in Europe. So that's the situation in Europe. In India, we have a 20 megahertz, which is the same as the European 1818 to 1900. In US, we have a 10 megahertz, which is, if I now recall right, from 1910 to 1920 megahertz. And in Japan, we have roughly 10 megahertz as well. China is the area where in my understanding, we are not having a spectrum for this one. But that is a bit unclear because there are different information on that perspective.
Okay. What is the maximum coverage for a smart metering network?
That's I think this is one of my favorite things, because people think that the coverage equals the range, and this is not the case. So if you talk about really the wireless coverage, so it's endless. So because every single smart meter is improving the coverage. So wherever you place, and let's say if there is let's take number 2 kilometer range between the 2 meters. So you can every 2 kilometers, your range will be improved. So, but what we really see is the bigger challenge is in a dense deployment. So, and because you need to transmit more and more data, and when you increase the range, normally when you put the more bit rate, your time on air is more. You use the more spectrum. So actually, the high densities are bigger challenge in smart metering than in a kind of rural areas to cover. But like we've been already proving that in sub-gigahertz in Nordic, so you have both very dense city centers and then rural areas in very non-deployed places in the world. So both are covered, but then if you think about the scale, so just to give the number, one network can handle 4 billion devices in a one network. So, and if this is not enough, put the 2, and then you have a 8 billion.
Yeah, and maybe it's good to understand that this is not to replace cellular completely. We obviously want to challenge cellular for the use of IoT, because in most cases, those installations are campus level, city level, or building level, or room level even, where it makes a lot of sense to let the devices to make the network formation, optimization, and what this really enables is super high spectrum efficiency, because every link optimized automatically the impact area when they are communicating. But there is still room for, obviously, for LB1 and cellular in cases where you have very, very few in very, very sparse situations. But those are also opportunities to use as a backhaul, especially cellular, because it has more bandwidth to this type of networks. So in a campus, you can survive with one gateway, quite likely, because with private 5G range that we just discussed, it's a very high coverage, because every node you install is a new kind of a base station. So that's the idea, and the flexibility and for the backhaul to use whatever available. It can be Wi-Fi, it can be fiber, Ethernet, and that makes it super versatile.
Yeah, and a combination of that. So you can have in the same network different type of backhauls.
Yeah, and you can have the backhaul different in different continent if you need. But still, the assets themselves, they are globally accessible because of the global band and global standard.
Yeah, and Teppo, maybe you can also mention on this one, we have a question on that we say 3GPP is not doing anything about MT or massive machine type communications, but there is narrowband IoT, there is Cat-M, and these are low cost. So anything you can say on the cost side?
Yeah, so this whole triangle is occupied by cellular, but I think we can all say that 5G didn't bring anything new to the MMTC corner. What is still left there is LTM and narrowband IoT, as you said. But this type of communication, first of all, it allows to use much cheaper hardware. The computing requirements for this type of communication is fraction from compared to cellular way of doing it. And when it's a single band, the radio front end is also much simpler than in cellular use, especially if you want to build global roaming. And that's the kind of the CapEx part. But it really starts to kick in the difference when you look the OpEx part. If you and typically you need to build a monthly subscriptions on top of that for the data. That's obviously a business question for the companies who are implementing products based on the standard. Wirepaths model today is such that the data is free for the end user.
Yeah, maybe I'd give the business perspective that think about the indoor lighting. So would you put the 2,000, 3,000 luminaires in a smart building to use the LTE-M or narrowband IoT for the communication, and especially when the low latencies are required across the network? Or then, on the other hand, we see that quite many applications that are battery operated. It doesn't mean that they send the data once package per day. They actually send the data continuously. So when you are battery operated sensor, you need to send the data in level of minutes, so continuously, and still have a 5 years battery life. So this doesn't combine with what is cellular is bringing in a 5G corner.
But also in a more sparse installation. So we have deployment in Greater Oslo for about 700,000 electricity meters in a single mesh network where you don't have any single rooftop antennas. So every meter is basically the antenna, if you like, and the full 100% coverage can be achieved by the meters alone, including basements, which is very difficult to achieve with on-ground wireless technologies.
Yeah, and I'm conscious we've run our time for our webinar, but we have a lot of people still on the line and lots of questions remaining. So I suggest we take a few more questions. One on security. What's the status on security and encryption?
Maybe I take that one.
So I'm a middleman here. I'm moving the speaker.
So the security part is this is also a bit associated on the data discussion we had earlier. There is a different security frameworks for the end-to-end security for which is related on the what is the application framework you are working with. And the intention on that area is that we must be as compatible of those frameworks what comes about the end-to-end security for the data. In the system itself, for the mesh topology and also the star topology, we have a MAC layer security which is encrypting and have also the integrity protection for the messages that nobody can tamper on those ones, and they are part of the existing specification as we speak. And currently we are using the same level of encryption algorithms what the LTE and 4G is using. And my understanding also 5G is using on the encryption AES 128.
Thank you. Then we have a question on Wirepaths private 5G that will work inside and outside. So a question on that, will it work also outside? And if yes, what kind of infrastructure would you need outside, for example, for asset tracking?
Well, I don't see any difference. That of course it could work in outside as well. This is a matter of more on the hardware itself and its capabilities to operate outside.
Yeah, and I would just come back to the fit for the purpose. So we are not saying that this is a fit for every single use case out there in a massive IoT either. So you need to always study that what is feasible, what makes sense, and I'm a big believer that the areas that we work, you don't need to build the infrastructure. So if I take like a citywide network, so once you deploy the private 5G, Wirepaths private 5G inside of the street lighting, you have a very nice and dense network covering everywhere in a city where the people are, where the assets are. Then if I look the logistics chains, already in a massive, which is using 2.4 gigahertz, is a fit for the most of the use cases. Why? Because what is interesting? Interesting is the kind of business event where the goods are changing the ownership. And also the inventory event. Is it arriving in this warehouse? Where it in this warehouse? Even in the big logistics players, these are the events what they are get interested. It's not between, it's when it enters, when it leaves, and what happens inside of the certain place. So it's really about that we are not trying to compete in the case where the cellular 5G is a fit or even a 4G is a fit. There is lots of use cases, but when you need to kind of scale affordably in the millions of units in one place, that's where our benefits are coming.
Then we have a question on what is available today and what could directly be ordered from Wirepaths already today.
Sorry, I missed.
Okay, so today you can start already with the Wirepaths Massive. So our SDK is available in open source in GitHub. So if you go GitHub/Wirepaths, you can look our SDK. And the same SDK is going to be very similar for the private 5G. All of our kind of existing partners which are going with the private 5G, they already kind of do the implementation with the existing hardware. So you can really work with the 2.4 gigahertz or sub-gigahertz products which are using the Massive. There's the same APIs, it's the same functionality. You can test your end-to-end and then in a parallel actually doing the hardware design for the Wirepaths private 5G product and then merging those next year when it's in a commercial availability.
Okay, thank you. Teppo, would you like to say any final words? Now we're a little bit over time already, and I think we can the questions we had no time to answer, we will be able to handle them afterwards. And also, please feel free to reach out to us.
Indeed. So let's stay in touch. And I'm just overwhelmingly humble and excited about the interest. We are clearly seeing a big change around this topic, and like the amount of attendees, the more than 50 questions during this session, and so on. So we are looking them, and we try to come back on those to the people who have been sending them. But yeah, this is an ecosystem play. So only being active and only raising the flag for this makes it happen in a big way and in a timely manner. And we are super committed. We know many of our customers are super committed as well. And so we welcome as many as possible to the standard, and we are eager to discuss to solve your problems, whether it's a Wirepaths Massive or Wirepaths Private 5G. So with that, thanks also to the team for organizing the event. Thank you all who are still there and who are watching the recording. See you soon.